In this example, we're going to be balancing redox equations using half reactions. Our first step is to determine our oxidation numbers. We're going to look at cobalt, which is +3, and on the other side, it is +2. Here we can see we've had a gain of electrons. Remember, electrons are negative, so when we have a gain, my number got smaller. This is our reduction. We also have gold here, which is changing from an oxidation number of 0 to +3. Here we have oxidation because we have lost 3 electrons to become more positive. We're going to separate these half reactions, and we're going to take step number 2, which is balance the charge. And we're going to add in our electrons. So over here, if we look at our oxidation, we have gold turning into gold 3+. And we're losing electrons here. So we have to indicate that by showing that our electrons are coming out of our system on our product side. If we look at our reduction, we have cobalt 3+ turning into cobalt 2+. To change from cobalt 3+ to cobalt 2+, our electron goes on our reactant side. We're adding 1 electron to change into cobalt 3 to cobalt 2+. My next step here is to determine the lowest number that is common and multiply my electrons and my substances by it to make everything common. So here I can identify that I need to times my cobalt species by 3 so that my electrons are even on both sides. This will give us the same thing for gold, but cobalt will now be 3CO3+ plus 3 electrons goes to 3 cobalt 2+. In my next step, we're going to add our half reactions. We're going to remove any electrons or molecules on both sides, and if we had spectator ions, we're going to add them back in. This case doesn't have spectator ions, but let's give this a look. So we have gold going to gold 3+ plus 3 electrons, 3 cobalt 3+ plus 3 electrons going to cobalt 2+, 3 of them. I can see that I can cancel out my 3 electrons on both sides, leaving me with gold plus 3, cobalt 3+, gold 3+, and 3 cobalt 2+. If we wanted to check if this question balances out, we would look at the charges on both sides. They would need to be equal. Here on this side, I have +9. 3 times 3 is 9, and it's positive. Here, I have 3 times 2, which is +6, plus +3. I have +9. So my balanced redox equation is this answer here.